functions today, which you did in algebra. When I'm talking about an exponential function, it's something like a to the x. A is a positive number. And is called the base.
Can I borrow a pencil?
Yes, I'm sorry, you told me that, and then I didn't hand it to you.
Thank you.
You're welcome. And x is a variable. And we know that is called the exponent. So we've dealt with exponents a lot. The difference is an exponential function, the variable is in your exponent. So, if I just asked you to evaluate a few exponentials, so if my exponential function is 4 to the x, if I said f of negative 2, so that means 4 to the negative 2 power. What does a negative exponent do?
Puts it at the bottom.
So it's 1 over 4 squared.
16.
So f of 5 means 4 to the 5th.
1,024.
C, f of 2/3.
2.52.
Yeah. You could write this as a radical. We know that's just the cube root of 4 squared or the cube root of 16, but it doesn't work out. What did you say it was as a decimal?
2.52.
Yeah.
So you could give a decimal approximation as well. And we can have a decimal exponent. That's fine. So if I said 4 to the 2.15 power, plug that in. Calculators are over here if you want to grab one and join us. Do you want paper to write notes on?
Yeah.
Okay.
It's 19.67.
All right. So could we handle just evaluating basic exponentials like that? Okay. So when we graph them, you might remember from Mrs. Keller's class, we're really making a T-chart, but there's only certain points that you really have to plug in. So if our function is 2 to the x, right, so we know if we don't know what a graph looks like, we make our T-chart. So what do you want to plug in?
1, 0, 1, 2.
All right, let's try that. So if we put in the 0, I'll flip them. You said 0 first. It doesn't really matter. If I put in 0, what's 2 to the 0 power?
0. 2.
It'd be 1.
Oh, yeah, everything.
Yeah, anything to the 0 power becomes a 1. If you put in a 1, what's 2 to the first?
2.
Okay, so 1, 2 is a point. If you put in a 2,
4.
all right. And what's going to happen when I keep plugging in positives? Just going to keep increasing. Let's try some negatives so we can kind of see. If you put in negative 1, So what does a negative power do?
Puts that bottom one over two.
Mm-hmm. So negative 1 gives us 1/2. If you put in negative 2, you would get.
1 over 4.
Will you ever do 2 to some power and get 0? No. What's happening is this is just slowly, and well, not really slowly, pretty quickly increasing. Right here, the x-axis is kind of like a horizontal asymptote. We're getting close to it. We're not actually crossing that line. What's the domain of this? It hits every x value, so negative infinity to positive infinity. The range, this one starts at 0 and goes up forever, so it's just a 0 to infinity. Is this graph increasing or decreasing? Increasing, good. All right, so then the question is, what points are necessary? Is it really necessary to plug in this many points if we kind of know what it's going to look like? We know it'll have an asymptote, we know it's rising. The bare minimum, when we graph these, we always put in 0, 1, and negative 1. And that would be enough to basically tell if it's increasing or decreasing and get your graph from there. So, if I asked for g of x equals 1/2 to the x. So if I want to graph that, you could again plug in a bunch of points, or if you want to use what we just said, you really only need 3 points, 0, 1, and negative 1. So what's 1/2 to the 0?
Oh, 1.
Yeah. Sorry, you could put them in any order. So if you put in 0, you get 1, always. If you put in negative 1, 1/2 to the negative 1, that would flip it and you get 2.
And that's it.
And if you put in positive 1, 1/2 to the first,
Oh, 1/2.
and so when my base was less than 1, my graph was actually decreasing this time. It just flipped it. Instead of going up, it went down. What's the domain of this one? What's the range?
0.
We don't ever hit the 0. We have an asymptote. The x-axis is our asymptote there. But it hits everything above that. All right. Are those okay?
I do somewhat remember this, yeah.
You do?
Yeah.
All right. Why don't... Do you guys want to graph a couple more basic ones like this, like a 4 to the x or a 1/3 to the x, or do you...
We can move on.
Okay. Why don't we
Same
try
deal.
some transformations of those, and that'll probably be as far as we get. So we'll just do transformations until we feel comfortable with those. Okay.
Okay.
Let's do. All right.
Oh, she gets a graph, of course.
I do. Give myself graph paper, just not you. All right. So, what's my transformation this time? What's different on this one?
Reflect over the x-axis.
Yeah, a negative out in front would flip or reflect over the x-axis. Okay, so my parent function here is the 3 to the x. Let's graph that first. Now you can write out your order pairs. You don't have to. That's completely up to you. You just have to be able to plot them. If we did negative 1, what's 3 to the negative 1?
1/3.
So 1/3. And 3 to the 0?
1,
And 3 to the first?
3.
So we have negative 1, 1/3, 0, 1, and 1, 3. That's my parent function, so that's my dashed one. Okay, so then my transformation, you guys told me that a negative in front would reflect this over the x-axis. So it's just going to take those 3 points and flip them across the axis. So we're just getting this mirror image down here. Does my asymptote move when I do that? No. So we still have the same asymptote. It did switch my domain and range. Well, my domain didn't change, did it? That's always negative to infinity. What's the range this time? Negative infinity to 0 because it was below the
Go behind,
axis.
let me catch up.
Okay, sorry. I got excited. So what would this -2 do to my graph?
Right 2.
So my parent function is 4 to the x. So t-chart, like I said, optional if you want to write it down, but you're plugging in -1, 0, and 1. 4 to the -1, the negative power just flips it, so that's 1, 4. 4 to the 0, anything to the 0 is 1. And 4 to the first is 4.
Now we just gotta move all right to.
Got that parent, and move each of those points to the right 2. So my asymptote didn't move there. What would cause your horizontal asymptote to move?
Shifted up or down.
Good. Doing okay with these so far? Do we want a harder one? Okay.
We're flipping it over to y-axis?
Yes. If your x has a negative, that's a flip or reflect over the y. And the -3,
Down 3.
So, we have to explain the transformations before we do them all times?
I would like that.
Okay.
Parent function is just our basic 2 to the x, so our 3 points. 2 to the -1, so that would just flip it 1/2. 2 to the 0 is 1, and 2 to the first is 2. So we have -1, 1/2, 0, 1, 1, 2.
So flip over the y-axis, that's gonna be.
When I move down 3, what else is going to happen?
Horizontal axis is going to be horizontal asymptote.
Right, we currently have a horizontal asymptote on the x-axis. I'm going to move that down 3, and I'll go ahead and draw it in down here at -3, so that I make sure I don't cross that line when I'm drawing it. So this is my new asymptote. Okay, so if I take my point, flip it over the y-axis, so it would go to +1, 1/2, and then down 3. So 0, 1, if I flip it over the y, it doesn't go anywhere. Down 3. 1, 2. If I flip it over the y, it goes to 1, negative 2. And down. What's the domain? What's the range?
Uh,
Do we need more?
I mean, we did transformations quite a lot in Stackle.
Yes, we have done a lot of transformations. So I have a handout for you.